This is spring test number 7, part um, from sections 1-1 through 7-6. This is part 2. We're picking up on number 8. We have to graph the inequality 3x minus 7y is less than negative 21. This is not in slope-intercept form for us, so we want to make it into y equals mx plus b form to where we can graph it, where we know how to get to it. So in order to do that, we need to move our x terms over. We have positive 3x. Undo that by subtracting 3x. If you subtract 3x on the left side, make sure you subtract 3x on the right side. So what we're left with is negative 7y on the left is less than, you want it to say mx, so negative 3x plus b minus 21. Watch what's going to happen on this next step. We have negative 7 times something. Undo that by dividing by negative 7. If you divide the left, make sure you divide the right, both terms on the right, by negative 7. So that'll cancel out and leave us with y. Negative 3 divided by negative 7 will be a positive 3 over 7x. And then negative 21 divided by negative 7 will be a positive 3. But this time we divided by a negative number. Remember, if you divide by a positive number, it's okay. If you divide it by a negative number, you have to take that symbol less than and make it say greater than. And we looked at one like that yesterday on the bell work. There were people that caught that in all of the classes. So now we have slope-intercept form. We have mx plus b. B tells you where to begin. Our b value is 3. So on your y-axis, put your point at 3. Our m value is 3 over 7. 3 over 7. That means go up 3 and go right 7. So from that point, up 1, 2, 3, and to the right 7 times. That's where your second point goes. Again, this doesn't say less than, or this doesn't say greater than or equal to. It just says greater than. And since it only says greater than, we want a dashed line going between those 2 points. So now we have our line drawn. But remember, we have to shade one side or the other side. So pick one point. Remember, the easiest point for almost everybody to use is 0, because when you multiply anything times 0, it'll give you 0. So if we plug that number back into the original equation, remember, you can plug it into any equation you want. I'm just going to show you going back into the original one. 3 times not x now, 3 times 0, minus 7 times not y, but 0 is less than negative 21. Anything times 0 is 0, minus anything times 0 is 0 is less than negative 21. 0 is not less than negative 21. You can see at this step, this is when you have to evaluate if it's true or not. That is a false statement. It is not less than negative 21. That means everything over here is wrong. That means everything over there is false, which means everything shaded to that side is true. The rest of the inequality graphs are already in slope-intercept form for us, mx plus b. So we can go a little bit quicker with these. Our b value on the first one is 5. So begin at 5. Our m value is negative 3. Remember, slopes are always over 1 if they are an integer, because you have to do rise over run. That means down 3 and to the right 1. So from that point down 1, 2, 3, and to the right one is our second point. That says y is greater than. It doesn't say y is greater than or equal to. So that's, again, going to be a dashed line for us, not a solid line. Dashed line. And again, we have to shade one side or the other. You can pick 0, 0 because it doesn't go through that point, doesn't go through the origin. Plug in 0, 0 into the original equation. 0 is greater than negative 3 times 0 plus 5. 0 is greater than 0 plus 5. 0 is greater than 5. This is the step, this is the point you have to evaluate. Is it true or false? 0 is not greater than 5, so that is a false statement, which means everything to this side where the 0, 0 is false. So we need to shade the other side. Number 10 says graph the inequality. Much smaller, much quicker one right here. B's value is negative 2. So begin at negative 2. M's value is 2, which is over 1. Go up 2 and to the right 1. So up 2 and to the right 1. There's your second point. This time it says greater than or equal to. And since it says or equal to, now we can have ourselves a straight line going through them. So we have ourselves a nice straight line like that. And we have to shade one side or the other. Remember, it doesn't go through 0, 0. That's always your easiest bet to pick. Plug in 0, 0 into your inequality. 0 becomes y is greater than or equal to 2 times 0 in place of x minus 2. So 0 is greater than or equal to 0 minus 2. 0 is greater than or equal to negative 2. Evaluate that statement. 0 is greater than or equal to negative 2. So now it is a true statement, which means everything to the side of 0, 0 is true. Number 11 says write it in slope-intercept form. This is actually going back a few steps from what we've been doing. So just move your x terms over. You have minus, you want it slope-intercept form. You have to know that that means y equals mx plus b. Get rid of minus 6x or negative 6x by adding 6x. If you do it to the left, do it to the right. A lot of y'all are catching on to the fact that you don't have to even show that step, because if it was negative on the left, if you have to move it over, you know it becomes positive. But we have 2y is greater than or equal to, remember you wanted to say mx plus b, so put 6x first and then minus 34, the plus b part. Get rid of 2 times something by dividing by 2. Make sure you do it to both terms on the right. That'll leave you with just y. 6 divided by 2 will be 3x, and negative 34 divided by 2 will be negative 17. We divided by a number here, but we divided by a positive number. So there's no need to flip the inequality from greater than or equal to less than or equal. There's no need to do that. Greater than or equal. So y is greater than or equal to 3x minus 17 is slope-intercept form, because that shows you mx plus b. So if you needed to identify the b, you would say negative 17. You identify the m, you would say 3. Number 12, okay, here's the first one that you can't really see the shading very well on your graph. Okay, notice what the b value is. In order to write the inequality, and we did a bunch of these yesterday, you want to write it as an equation first. Y equals mx plus b. And that's called slope-intercept form for a reason, because it shows you 2 things. It shows you a slope, and it shows you an intercept, more specifically a y-intercept. Your y-intercept is where it crosses through your y-axis. So it crosses through at the number 1. So your b value is 1. Your slope tells you how many times it rises, which means up or down, over how many times it runs, which means left or right. So it's actually going down once and to the right 1 time. Down once means negative 1, to the right means positive 1. So your slope would be negative 1 over 1, or simply negative 1. So if you'd write this as an equation, you would write y equals, you would leave a space and then put x, and then leave another space to where you can plug in m and you can plug in b. You would plug in m, you can simply leave it as negative 1. It doesn't have to show over 1. Negative 1 in place of m, and b would be positive 1. So your equation would be y equals negative 1x, or simply negative x. You don't have to show the 1 coefficient, plus 1. But we're not writing an equation. We're writing an inequality, so we have to take this a little bit farther. We need this to say y, instead of equals now, y is something negative x plus 1. And again, that something is either going to be greater than or less than, or one of its versions. We can go back to what we do using 0, 0, since this line does not cross through 0, 0. Notice we have that point free. We can plug in the value 0, 0, because that point is named x comma y 0 comma 0. So in place of y, you can plug in 0. In place of x, you can plug in 0, because it's negative x, plus 1. So what we have is 0 is something, again, I'm leaving that is something open on purpose. Something negative 0 just means 0 plus 1. So 0 is something 1. In this space here, we either need to write greater than, or we need to write less than. Okay. Now we have to determine, do we need to put a true statement, or do we need to put a false statement? The way it's shaded will tell you that. Notice your shading is coming towards the point 0, 0. So that means that that point is true. So what we want to do is we want to create a true statement at this last step. So 0 is less than 1 would be the symbol we're going to use, less than. So you go back to the original equation that you can, not the original one, but the original one you came up with. Let's move all these little guys over. Put them back where they belong. The original one you came up with, y equals negative x plus 1, and you want to put y is that something negative x plus 1. Y is something negative x plus 1. You want to use that symbol that you just came up with, less than. And then the last step you need to do, you'd have to determine, is it a solid line or a dashed line? And since it is a solid line here, it's not just or less than, it's less than or equal to. So your inequality, and I'm way off on here, I'm way over on the side for you guys, but y is less than or equal to negative x plus 1. 13 was another one that you really couldn't see the shading, but this one's a whole lot quicker to do for the simple reason that it's only dealing in one variable since you see a vertical line. That gives you the x value. Notice if you did an x comma y for each of the points up there that follow on that line where you're talking about integers, your x value is going to be -2 the whole time. So your y is going to change, but your x will be -2 the whole time. So what that's saying is everything that is smaller or everything that's less than -2 are the numbers you're talking about. So x is less than -2. Get horizontal and vertical lines are very, very easy to determine what they are. And it's just less than since it's a dashed line. It's not or equal to, and it's less than -2, and that's just all you have to do for that one. X is less than -2. And then number 14 was the third one you couldn't really see the shading.